Hello. I thought as we wait for New York Open today to do some coding together. See what happens. I don't know if you guys are gonna like it, but I am also a coder at heart, and I do this a lot. And in the past few days, as you know, I'm coding an indicator. I'm coding lots of stuff. In the past few days, I've been working on some statistics. So I have some code that analyzes. So I have this data, which is all the closes, basically all the candles, H4 candles since 2016, provided by TradingView. And I've been writing some stats, H4 stats. So I've been coding with the help of OpenAI, large language model O1, some statistics about the closes, how much the 4-hour candle expands, how much they expand after a breakout, how much they expand. Hey, this is going to be hidden. Let me put myself here for now. And I generate some charts. So this you might have seen from my tweets. So how to explain it? Let's see. Okay, so when did there's the candles I'm interested in are the 4-hour candles that are between 2 and 6 a.m. It's the London session. 6 and 10 includes the New York Open, and then 10 to 14, 10 to 2 p.m. New York time, which is the AM session of New York for Nasdaq. And so these charts show what's the distribution. So how much will a candle retrace before expanding and going for the highest point of the candle in some conditions. So as you can see, the 2 to 6 H4 candle, on average, it will retrace almost half of the whole length of the previous candle before expanding. And if you know what the standard deviation means, the standard deviation, so the range is between -1 and +1 standard deviation, is the range that 2 out of 3 times a certain probability distribution, a certain value will fit between those two values. So that means, in general, if you want to know how much it will, the 2 to 6 H4 candle will retrace before expanding, on average half of the previous candle, it can get as far as the 91%, almost retracing the entire previous candle and starting from basically where it closed. So in general, you should imagine this as a curve. Well, you see this curve, it's a little bit more probable that it will retrace just a little bit, but on average it will retrace almost half and then expand. These are just some statistics I was calculating to get a sense of what could be set as targets, what did you expect, when could you consider the manipulation of the London manipulation, the Judas string, to be over, and so on. And I have a friend who's been working on this for a long time, creating models based on standard deviation levels, and has become quite accurate, and he has all these levels that he has shared with us. He's on Twitter. His name is Jumbo. We'll share the Twitter in the description below, and you should go and follow him. The thing that he has found out is that many times the candle, when there is a retracement, basically a manipulation before expansion, there are some specific levels that will be touched with a lot of with a lot of precision many times. And one of the levels is the 120% or 20% plus 20% retracement of the candle. So this is the 2 to 6 4-hour candle that I am highlighting with my mouse. And if you see the 2 to 6 candle, which is the let's say it properly, we can check it together. So the 2 to 6 candle, what it did when it opened it went below the previous one by 20%. So, and then it expanded up to 1, 1.5, 2, 2.5%. So what we want to do is measure. What I would like to build is a program, let's say a statistical analysis that takes every time this close, right? This the close of the 2 a.m. where the 2 to 6 candle starts, measure how many times we swipe below to close above, how many times we reach 1.2, 1.3, 1.5, and so on. And if we reach 1.2, how many times we reach the opposite, and so that we can draw some statistical conclusions about the 2 to 6 candle, and maybe this can help us build a model for London and then a model for New York and so on. So that's what I was busy with, and what I would like now to narrow it, because it just happened today. I would like to get some statistical analysis from 2016, all 4-hour candles from 10 to 2 a.m. and 2 a.m. to 6, and measure how many times, how deep is this usual retracement manipulation before expansion on the opposite sides, how many times it happens, and get some stats. So sometimes this candle will actually continue to the downside. In this case, I want to see situations where it will wick, where it will stop on average, and how far it will go on the other side for reversal candles. So that's what I want to do. I thought if I start coding, it's going to become very boring. I can't talk while I code, so it would be very boring. So what I can do is pause the video, and when I have something that we run it together. So that's going to be an accelerated coding session that we do together. If you find it interesting, you let me know in the comments. Otherwise, I won't post this stuff anymore. So I'll pause the video here, and I'll be back in a second. Let's see if I have a curtain for you. This one? All right. Be back in a second. Hello, I'm back. It's very interesting. So I've been coding the function that, so keep in mind I was trying to get to this, right? So I'm going to show you the logic I was trying to build, and then we'd verify if we did something, or if O1 made a mess. Okay, so if you remember, so what I want to measure is when, for example, in the scenario of a down close candle, so 2 to 2 a.m., that 10 to 2 a.m. candle closes bearish, cannot breach the previous day low. It does a sweep on the between 2 and 6, touches 1.2 of the extension or the retracement, and then reverses. So I want to measure when the candle cannot close below this low, statistically, how far down will it go and how far up back will it go. So let's say a statistical analysis of basically the London Judas swing based on 4-hour candles. So the way I had coded it is like this. Okay, so I asked O1 to write some code for me. So the function I wrote was this. So this is the condition. So if the previous candle closed, so we can double check the logic as we read it. So the previous candle close is between 10 and 2, right? Previous candle close is below its open, so it's a down close candle. And the current candle between 2 and 6, the close is above the low of the previous candle, right? Then we want to measure the low to the high of the other candle, how much it is compared to the previous one. So the in this case, the low to the previous candle high as measured by the previous candle length, right? So this is going to should give us an average, for example, 120%. And how much will it expand, right? So we want to draw the expansion to the high of the candle from the low of the, let's say from the the low of the previous candle, so we can measure it in length of the previous candle, how much higher of the previous candle will it go, and then I can plot it, right? Okay, so this is what I wrote. I had already some code. I did write, so now it did write this. Well, he added some comment to this. We don't care. And then it actually modified a little bit the stuff I wrote so that it would have a type and a manipulation, a type, so that it could then use it below. Okay, I understand. And then I said, okay, do this analysis for, I can show you what I was doing here. So I did ask O1. No, does this camera annoy you? Let me move it. In the center, right. So I said, I'm using the script and I want to do some modifications. This is what I have so far. I wrote this function. Help me write the rest. So very helpfully, O1 has written all the code to plot the distribution, which he already did for me in other instances. And now just double checking what it did. You always have to check what it does. So we do sweep and reversal statistics. We apply the function that we wanted to measure for the 2 a.m. candle 6 and 10. And then we extract all the manipulations and all the expansions, right? So we do it. Mean manipulation, mean expansion, and then we draw it. And the drawing is very, very interesting. What is this? I'm very impressed, but so what I like to see, and this is what actually, maybe I need to, it merges, so the calculation is not correct, because bullish and bearish, they are now spread out. So you see the plus and the minuses depending on the bullish and bearish cases. So we want it merged, basically. We don't care, right? So you can see that actually there is some bias towards bullish or bearish. The numbers are 6 to 10 is exactly specular. Now this is very interesting, but if you see what we're interested in is that the number is 123. And this is wonderful because this matches. Yeah, look. It's beautiful. I need to merge those two sides that are two mirrors. We need to be merged into one. We don't really care about the slight bias for longs and shorts in NQ, I think. But what this tells us is this: is that in general, the mean. So the standard deviation, so 2 out of 3 times, when it's a manipulation that's going to lead to a reversal, it's going to go to 123, right? So this is the 120% retracement between 2 to 6. So 2 out of 3, the range of the retracement will be between well, you can see it, right? It goes from, there's a lot of instances where it goes exactly to 100, close to 100. Then it starts to get lower, and if you get the tail end, discard the tail, most of the times it will land at this point. Well, this point is 130 and 120. So I need to merge the two sides. So maybe we can try to do it. Let me pause the video a second and don't see me code. I don't think it would be fun to just see me fiddle. Let me do this and then I'll come back with a different chart that should be unified. But I'll commit this because it's pretty cool. Actually, let me just do it. A reversal expansion starts for candles with scenarios sides. Okay, I'll pause this for now. I'll be back in a second. 1 second, curtain. Right. Okay, I just basically removed the sign that was messing this up. And okay, this makes more sense, right? So I think I need to double check what I didn't do. The expansion, I didn't change the sign. Okay, so for the expansion, I still have the two sides split. No, this is pretty cool. If so you see the mean now is 120. The mean is 120. And so how much it will manipulate, it's standard deviation. So between 71 and 166, 2 out of 3 times, when it manipulates, it's going to be between these two, and on average, it's going to be in the middle at 120. Interesting. And for the 610 is 117, and for 1045 is 108. Could even maybe do the calculation without all this, let's say, dividing it in these buckets, and just calculate whenever there is a configuration where the sweep, there's a sweep and a reversal on H1, on H4, how does that compute? Let me change the signs of this. I'll be back in a bit. Maybe we can do it while you watch. Okay, let me move this out. So the expansions also are reversed. So high to low, low to high. This should always be, again, high to low, I think. Let's see what happens if I re-execute it. The question is, there's a case for actually keeping it this way. All right. Yeah. Very interesting. Very interesting. So the numbers are unchanged for the sweep and reverse for the manipulation legs, and for the expansion now they're merged, and you can see that there is a sort of a, so how much will the candle expand back, and it will go 2 times the previous one is the standard deviation. So when it expands, how much will it expand over the previous candle? Let's put the chart to it so that we can make it visual. This one. All right. So in this case, which is exactly the case we're looking at, we manipulated up to 120% down. So see, the mean is 120. There's quite a peak at around these levels, but between 70 and 160, let's say, those form the bulk. The 2 out of 3 fits between 70 and 160 with an average of 1.2. And then how much will it expand? So this level would be 100%. The model I'm marking here would be 100. And it tells us that on average, it will expand. This immediate candle will on average expand 140. So I should arrive here. And, between 58, we can put this value into this, which is, so we have, if these calculations are correct, what we want to put is for the, let's say, manipulation side, we want to put in 118. So now we have 1.2 would be 1.8, and then what else? The value that we want to put in is 71, so on. $71, and then maximum 1.0. 6, 6, 4. All right, and then for the expansion, we have them there. We would put, instead of -1, -0.5, we would put minus, well, -1, maybe we leave it, but we would have minus 0.59, and then we would have 140, so 141, and then we would have 2 to 1, 2, 2. Okay. So this is how it would look like with our values, right? With this statically enhanced values. Look, interestingly enough, the 1.6 will be the previous day low, which we failed, which we failed to get to, and then we reversed. We actually closed on 59, could not get to the 1, and the following candle did go quite high, but then our stats stopped there. Right. Okay, so this is the calculations I wanted to do. I need to do some double checking if they are making sense. I want to hold down this 0, 2.6 sweep reversal levels, right? So that's how I was planning to use this. So when a candle, when the 2 a.m. 2 to 6 candle sweeps, and then you expect it to reverse, you can expect it to touch. We want to add that this is the 118 is the mean manipulation. So we got 2 to 6 mean manipulation, and then is this is 2 to 6 one standard deviation manipulation, and this one is the -1. This would be the -1 manipulation, and then the mean expansion would be this. I am slow. Mean expansion, and then the 2 is the standard deviation expansion. All right, and then we have a 58, which is the -1 standard deviation expansion. Okay. All right, so this would be worth using for backtest. So my next step would be to use this value, just backtest to the 6, when there's a sweep and a reversal and lower time frames, and you expect a continuation to the upside. Check that where the manipulation, what the manipulation has reached, and then take a trade. All right. I'm just a little bit confused by this 71% value, because I'm just a bit confused by this 71% value, because depends how I measured it. So I measure, it's the 71% size of the H4 candle, and that will be the manipulation. So in many cases, if this is the candle we're looking at, right? Yeah, I understand. So if this candle doesn't look like this, but it looks like, let me draw it differently for you. So imagine the candle looks like black candle, right? I have a black candle somewhere. Candle. Yeah, so if the candle is not like this, but it's not like this, but it's here. So it closes very high and there's a long wick, right? This whole extension, the manipulation might get down to 70% of this before bolting up. So that's what it means. It also depends how thick, how big the distance between the open and the close. It's just to understand if I'm writing it correctly or not. So if this value 71% does make sense or not. All right, this is concludes my pseudo coding session with you guys. Let me know if you found this interesting. This is what I've been busy with for the past few days, just doing. And let me zoom in on myself. Yes, very, just so I can say goodbye. Thank you for watching. Hey, I appreciate your comments on how useful you found the indicator I'm working on. You're all waiting for the pro version to be released. That's gonna happen when we reach 1,000 subscribers on this channel. Like and subscribe. And let me know if this sort of stuff you find useful. I find this chart and these levels very compelling, to be honest. And I'd like to backtest a model, an FX replay. We'll probably do that before the open now. Thank you for watching. Maybe some Call of Duty. No, we'll see. Thank you. Bye. Ciao. Where's the music? There's the music. Bye, everyone. Ciao, ciao.